So let's start off by talking about some of the most common injuries in car crashes. First are back injuries, which are very common when a car is hit. The spine is not built to sustain a heavy impact like in a car crash. Next are internal injuries. They occur when the body is hit with debris. This type of injury would require emergency treatment. Finally is whiplash, which occurs when the brain literally slides inside the skull and can occur at speeds as low as 15 miles an hour. While there are more types of injuries that can occur, these are the most common. Nearly 1.25 million people die every year from road crashes, which is over 3,000 people every day. This is why this topic is so important. Now let's specify some of the more common injuries to the head. First up are concussions. Concussions are one of the most familiar types of brain injuries, especially when it comes to car accidents. It is the result when the brain receives trauma from impact, some momentum, or movement change. Next are contusions. Contusion is just a fancy word for saying bruise, but when it involves the brain, it is much more complicated. It can even be as serious as enough to require surgical removal. Finally is penetration. Penetrating injuries are just like what they sound. An object has penetrated through the head and into the brain. First, we are going to focus in on head-on collisions. The most severe type of head-on car crash injury is the traumatic brain injury, which happens when the skull is fractured. This injury can cause contusions or tears in the brain. An estimated 2.8 million people sustain a TBI per year. Of those people, 50,000 die and 282,000 are hospitalized. Car crashes remain the leading cause of TBI-related deaths among 15 and 19-year-olds. Another type of injury sustained in head-on collisions, but less severe, is the breaking of facial bones, which happens when the face and inner bones are damaged, and depending on the severity of the crash, it may require surgery. Next, we're going to talk about T-bone crashes. Did you know 51% of deaths in car crashes occur from T-bone accidents? And the death rate in T-bone crashes is 60%. Concussions are the most common type of injury sustained in T-bone crashes and are the result of blunt force trauma or blows to the body that result in the twisting or rotating of the brain. Results of a concussion include headaches, fatigue, chronic pain, loss of coordination, depression, and many other things. Whiplash and concussions are the most definite injuries caused by side impact car crashes, but the injuries to the limbs and the chest remain just about as common as those sustained in rear-end or head-on collisions. Finally, we are going to talk about rear-end collisions, which are probably the safest form of an auto accident. They account for only 6% of deaths in auto accidents, but they account for 28% of total auto accidents. You have less of a chance of a brain injury in a rear-end collision than a head-on or T-bone collision. Most of the time, a head injury occurs when the driver or passenger is not wearing a seatbelt. Some of the most common head injuries include muscle strains in the neck, when your body moves back and forth, concussions when the brain keeps on hitting the inside of the skull, and objects literally just hitting the inside of your head. So how does all this relate to Newton's first law? Newton's first law says that an object in motion will stay in motion unless acted upon by a net external force. When you're traveling in a car, you are going the same speed as the car. When you get into a car crash, the car's motion is being stopped by an external force. The car will continue to want to move forward based on Newton's first law. And in the same sense, you will also want to keep on moving forward since you are moving with the car. This is why there are seatbelts and airbags to protect you from sustaining injuries. Seatbelts help you to stop moving forward, and airbags increase the time in which the impact occurs and decrease the force exerted on you. Next, we're going to talk about how car crashes relate to Newton's second law. Newton's second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force, and inversely proportional to the mass of the object, or now by the equation F equals ma. What this actually means is that the unbalanced force that acts upon an object depends on the acceleration and mass of the object. So in the case of a car crash, if we had a car that weighed 1,500 kilograms and was moving at a fast rate, The unbalanced force that it would take to stop that car would be greater than a car that only weighed 1,000 kilograms and was moving at a slower rate. It's also important to note that it would be better to be in a larger car when involved in a car crash. For example, if you were in the 1,500 kilogram car and you collide with the 1,000 kilogram car and both cars were moving at the same rate, the person in the 1,000 kilogram car would most likely be injured. This is due to the greater momentum in the car, which is modeled by the equation momentum equals mass times velocity. So how does the crash test data support what we have talked about? When we take a look at the data of a crash test for a head, provided by the head of the physics department, we can see that our data and statistics do prove what we have talked about. At the beginning of the graph, we can essentially see no g-force acting upon the head because there's no external force. Then we see a sharp increase in the g-force. This is when the crash actually occurs. From this data, we can see that the head wanted to keep on moving forward because of Newton's first law. It was acted upon by a net external force, though. Such a sharp increase in the g-force probably would have resulted in a concussion or a traumatic brain injury. When we see the leveling off of the data, this is probably when the airbags come in. It increased the time of impact while reducing the force. When we break it down, this scenario is exactly what we talked about. Thank you for joining me on this journey of the mind.